Hello and welcome to another episode of Ken Training, where we want to give you the training that you need to tackle projects like this one on your own. Today's training is going to be on troubleshooting a Liebert DataMate air conditioning unit for this small closet for some IT racks. So you can see two racks of equipment right here. Right back there is the Liebert DataMate. It's rated at 20,000 BTUs, so it's about 1.75 tons of capacity. And what's happening is that the unit is basically, the compressor is on and the room temperature is absolutely freezing. So our job is going to be to troubleshoot this unit to figure out what is wrong, what do we need to fix in this scenario. So let's get to it. I'm going to give you as much great content as I can in the shortest time frame possible, and I ask for you to do one thing for me, and that is to smash that like button down for me right now. And with that, let's go on with the show. Okay, the first thing we want to do is we want to look at the thermostat. Now this thermostat has a password, and the password is 123. Let me try to show you the display. So looking at the display, I got the fan set to low speed, and it tells you that the room temperature is currently 63 degrees Fahrenheit. So obviously we are absolutely freezing in this room. Now, first thing I want to do is I want to hit the menu button, and I want to scroll down to where it says status. Then I'm going to hit enter, and it's going to tell me that the thermostat is telling that it wants 0% cooling. There's no cooling signal, as there should not be, because it is 63 degrees Fahrenheit. So the thermostat signal is telling the unit you should not have a compressor on. I don't know if you can hear it in the camera, but I can tell you the compressor is running right now. Now this is not a standard thermostat. This is actually what they call I think they call it a control panel interface. I'll put a note there what the exact wording is. This is the wiring that's in the back, and the way that this works. So the green wire here is the ground. The red wire is a 5 volt, I think it's DC signal. And the black and white wire are the communication wires going to the PC board over at the unit. So it's not like a standard 24 volt thermostat. This particular thermostat actually cost, oh, by the way, here's the, I don't have it right here for you, but I'll give you the model number to this in the video. But this here is a control panel interface, and it basically costs $1,400 for this thermostat. The thermostat is telling the compressor that it should not be on. We can tell that from the status. That was the one I just showed you. Let's go over to the unit. In case you cannot hear it, there is the compressor. I got all the panel doors off so I could look inside this unit. Now, when you come over to the compressor, I'm going to take my field piece. I'm going to put it on amperage. So let's go to amperage AC. That's that one right there. I got backlight here, so let's throw that on. Let's throw that on a lead here. And you can see that we're pulling about 6.2 amps on this Copeland scroll compressor. So obviously that compressor is on, the fan is on, I can see it turning right there. So the unit's operating. Now let me show you the terminal board over here. Okay, this wire that I'm holding in my hand, that's the thermostat wire. The thermostat wire comes up to right here, and it lands on those terminals that you see right there, okay? Now, from the terminal, by the way, the PC board that all of this is communicating with is located right there. This is the PC board. There's a transformer down here, and there's a couple of relays that are down there too. Now, I was already looking at this and looking at the unit, and basically what you need to go over to the compressor is you need 24 volts on terminals 1 and 2. The white wire and the orange wire right here, they're the ones that go to the compressor contactor coil. So I've already checked it, and there is no voltage on these two terminals. So the thermostat and the PC board are not telling the compressor to run, but the compressor is still running. I'm going to pull off this panel here, and I'm going to open up the electrical. We're going to get right to that contactor, and we're going to verify that there's no 24 volts, but it looks like that contactor is stuck in the on position. Okay, here is your compressor. There, I took off the panel door that was right here. There's your compressor contactor, and you'll see that on the bottom you got, hold on a second there, look at all that blackened areas on those terminals right there. So this thing has experienced some pretty good wear and tear. Anyways, I've already checked for voltage across the leads right there at the bottom. Hang on one second. Okay, so it's hard for me to do this and hold the camera at the same time, but basically without holding the camera in my hand, I checked voltage from this lead to this lead right up here, which is the contactor coil, and it came out with 0 on my field piece. Now, so that means there's no coil voltage, but the compressor is stuck in. Now what I'm going to do, just for the hell of it, I'm going to take a screwdriver here, and I'm going to go ahead and tap on it. Let's just see if the thing stops right in front of me. Did you see that? All I did, I figured that was going to happen. I gave this a tap right here, and the contactor pulled out because there was no coil voltage because the thermostat is satisfied. So, this whole troubleshooting has revealed that the complete issue is going to be this contactor coil. I'll pull this contactor coil out, we will replace it, and so forth. So we'll do that right now. Just to let you know that had it been the PC board, that PC board over there cost $2,500. Had it been that thermostat over there, that thermostat is a $1,400 thermostat. So it's real important to make sure you troubleshoot this stuff correctly. This device here, I'll probably get this contactor for 30 bucks. Right? I can hear the ice dropping out of the coil because this thing had been running so cold. You can't really see the ice here, but I guarantee you there's some ice on the back side of that. I can hear it dropping inside the compartment. Okay, so by the way, as long as I'm here, as you can see, it's a Copeland scroll compressor. Refrigerant is a R407C. Here is the data plate for the condensing section. Let me just turn that upside down so you can see it. And there's your model number and your serial number of this particular unit. This unit is 2017. Water-cooled condenser. Okay, so there is your condenser right there. This portion that I'm putting my finger on right there, that's the condenser, and it's a water. These are your copper water pipes, and you can tell by the directional arrow and by the strainer direction that the flow of water comes down here. This is a bypass line right here. There's your shutoff valve if you needed to bypass, which we don't. So normally your water goes into the unit cold and it comes back as the heat is being rejected from the room through this pipe here, and it goes out into a water chiller at the cooling tower at the top of the rooftop somewhere. But this is controlled by this spring-loaded valve, which has a pressure switch located right here in the line for the refrigerant, So this way it can modulate the flow according to the refrigerant pressure, and it's adjustable. There's a spring tension right here in which you can adjust that in order to maintain it. But that's not my issue. My issue today is just simply this two-pole contactor coil. No big deal. We'll have that changed out in a few minutes. Okay, a couple of things I do to make my life a little bit easier when I go to do this job is that I just took a black Sharpie and just gave this one notch down here, one notch down here on the left-hand side of the contactor. On the right-hand side of the contactor, I took my leads that are connected here and here and gave them 2 notches on the top terminal and 2 notches here on the bottom terminal, just to label them. I also took my my ideal book here, which is for labeling electrical conduit stuff, electrical stuff, and I just have an ABC book here. So I just labeled the coil terminals with the top one being A and the bottom one being B right there. A little hard to see on the camera, but that's B right there. Although the wires are labeled, they can be difficult to read, so I could still use that and go through the schematic, but it's just easier for me just to do my own personal labeling with A and B and these notches. Now, right over here that I'm pointing to, this is the one item that is dangerous, which is the capacitor, the compressor capacitor. Now, the disconnect switch for this unit is located up there. I've already pulled it down. I'm going to use my meter, my feel piece, and go to NCV, non-contact voltage. And I'm going to go ahead and touch the incoming terminals, which are right here. And you can see that we have no juice. We are dead, so we're solid there. So I don't have to worry about incoming voltage coming to the unit. I'm going to take my needle nose pliers, now that I've confirmed that there's no power going to the unit. I'm going to short out this capacitor by touching the 2 leads and doing a dead short like this. And this just confirms that the capacitor is not holding a static charge, which could potentially take my life out. So now I'm 100% safe. I'm locked. I'm off up in the ceiling over there. And I've already labeled everything. I've snapped a picture of this to make my life easier, just to figure everything out. And all I have to do now is pull off all my leads, unscrew my contactor, a couple of Phillips head screws, take it down to the supply house, get a replacement. All right, here's your contactor just sitting here on the table. And you can see here your coil voltage is 24 volts, tells you right there. And it tells you the rating of this full load amps. Now we're running 240 volts, so it's a 25 amp contactor. And of course it's a 2-pole contactor. There's a model number there, but I'm just going to take this right down to the supply house. This pole over here, it's pretty much practically fused. Practically fused those legs together there, whereas the other one isn't so bad. But I'm not going to worry about cleaning anything up. I am just going for full-blown replacement here. Okay, I came down here to the closest supply house next to me near the job site, which is Johnstone Supply. And they were very helpful inside there. Not only was I able to get the replacement contactor for under $20, I also got a free donut out of the deal. I've already eaten half of it, and let me tell you, it's quite good. Now, when I look at my replacement contactor, of course I want to look at my ratings. Okay, so the 2 ratings that we want to look at are the coil voltage, 24 volts on the new one, and of course the old one here has 24 volts, so that matches up. And then on the pole ratings for the old one, we see here that under 240 volts it's 25 full load amps, and over here at 230 volts the full load amps is 30. These are actually rated 5 amps higher. So this will absolutely satisfy our... Oh, another thing that I look at is the footprint. Put the 2 back to back, and I verify that the holes match up. So that way I don't have to drill more holes. So this is an actual, just a drop-in replacement that's going to take care of our job. By the way, here's the model number of the brand new contactor. So it's an Eaton contactor, and the definite purpose contactor, and it gives you the 30 amp rating, 24 volt coil, and there's the model number. Okay, I had put a fan on there while I was gone to the supply house. I shut the fan off now to have as little ambient noise as possible for the video. There's still equipment running here that has fans that make some noise that I can't shut off. Now, I've already put the brand new contactor in, and it was a slam dunk in order to put it in because everything was all pre-labeled for myself. Let's crawl up here into the ceiling and take that disconnect switch right there and throw that on. Okay, now if you look at this, it tells you that there's a new alarm, there's a loss of power. So let's acknowledge that by hitting the enter button. Hang on. Okay, I hit the enter button, the alarm went off. You could hear the compressor turn on. It's telling you that the space temperature is currently 75 degrees Fahrenheit, right there in the top corner. You can see that. And you want to go to menu and you want to see what your set point is, hit enter. It tells you that your set point is 72 degrees Fahrenheit. So the compressor is running right now. Let's go ahead and check the compressor amps and see where they sit. Actually a little bit less than before. Now that we have two clean contacts, so that way they don't have to fight that resistance of those going through that bad pole, the compressor should be running smoothly. As long as we're here, might as well check the amp draw on all three legs. So that there is the blue leg is pulling 5.85. The red leg 4, just 3.4. We're fine. Okay, now I want to just cycle the compressor off according to the thermostat. Now we know that the set point is set at 72. Hit the escape button a couple of times, and that's going to give you your room temperature, which is 75 degrees. So I'm going to take my set point, I'm going to set it to 76 degrees, shutting the compressor off. So the way you do that is you hit the menu button. Then what you're going to do is you're going to hit set points, enter. Try to get this so you can see everything. Then you hit the enter button to change. I want to change it. It's asking for your password. You hit the up button. The number 1 populates up there, and then you hit enter. It goes over 1 digit. Go and hit the up button till number 2 populates. Hit enter. The 3rd digit, 3, enter. The password is okay, enter to continue. And now set point 72, enter to change. Let's bring that 72 up to 76, enter. And there you go, you heard it cycle off immediately. So this absolutely looks like it's working fine. There should be a built-in time delay. Let's verify if that works. We're going to change temperature set point 76, enter to change. I want to change it to back to 72, enter. Let's see if the unit does not allow the compressor to first start on, and it appears that it is not. I do not hear that compressor, which is a good thing. There's supposed to be a built-in 2 or 3 minute time delay to allow your refrigerant gases to settle out on the system. I'm going to hit escape and just go back to normal. We're at 75, we have no alarms, we're at 35% relative humidity. Okay, let's talk about that job for a second. The hardest part of this job was figuring out the sequence of operation and trying to troubleshoot that sequence of operation. On a normal residential HVAC system, when you go to your thermostat, you can take your voltmeter and you can put it on there, and you can determine if you have 24 volts going on the yellow cooling wire or the white heating wire very easily. But in this thermostat, on this Liebert DataMate, you cannot do that because it's not a 24 volt signal. As a matter of fact, the thermostat doesn't even operate off of 24 volts. It operates off of 5 volts. And the signal that goes from the Liebert thermostat to the control panel is like a computer-coded binary signal with ones and zeros. You cannot take your voltmeter and put it on there to determine what's going on. But what you can do is you can do exactly what I did do, which was you go to the thermostat and you go to status and you see what the thermostat is trying to do. Is it trying to call? And now in my case, I have a 2-speed blower motor and a single speed compressor. So it's a one-stage compressor and a 2 high and low speed for the cooling fan. So those are the options that this unit has. Now, when the thermostat calls for, you control the fan speed manually on this particular unit. So you have a fan high, you hit the fan speed and it goes either high or low. So you can control that. Now, when I was playing around with the system, it originally was on high and I set it to low, but I feel comfortable going back to high now that the system is operating normally. You clearly saw that the 24-volt contactor coil, compressor contactor coil, was bad. So that is, without a doubt, I feel very highly confident that that is the root cause of this HVAC system failure. As a matter of fact, you saw when I tapped on it with my screwdriver how it released. We knew that there was no voltage going to the coil when it was pulled in. Obviously, it's the contactor. That is easy to figure out and troubleshoot. Entry-level HVAC technicians can change out a 24-volt coil compressor contactor. That's not the challenging part of this particular job. There was just this Liebert communication between the thermostat and the PC board and trying to figure out what the exact signal is. Liebert's literature did not have any sequence of operation telling you exactly what should happen so that you could follow that along and try to troubleshoot that easily. So it just took a little time while I was off camera. Before, you saw me streamline it because I had already digested all that information to try to figure all this stuff out. I also want to mention that since I'm into the project, I took the air filter, which is right here. It goes on this panel door right here. I took that air filter off and took it to the kitchen sink and just washed it out so it's going back 100% brand new. And I put all the door skins on except for this one panel here that will go on last. I just took the contactor and left it here at the job site. Contactor changed out, put the date on it right there if anyone wants to observe that old contactor. Plus it also has the model number of the new contactor that we just installed. So good information there, not really taking up any space. Button up the ceiling tile. All I have to do now is put that panel door on. The thermostat is set already to 72 degrees Fahrenheit. We're good to go. That is going to conclude this video. If you got any good information out of this video at all, please smash that like button down for me right now. Subscribe to my channel, Ken Training. I will catch you on the flip side. Thank you.